Hello, it's me. So I'm going to be going over a couple of the examples on the worksheet you have to do for this assignment, just so you have an idea how to get started and all that good stuff. I'm going to give you some pointers. So make sure you're watching this video with sound. So if you're not already watching it with sound, you're not going to hear me say that, but watch it with sound if you can read my lips. So for the first one, it says determine and write the quadrant that each angle lies, and then sketch the angle in center position. So a good sheet to take out of your notebook would be this one. So this has the different quadrants, um, and that'll help you to do these problems. So it says determine and write the quadrant in which each angle lies. So if we're looking at 375, you'll see on this sheet 375 is not included in these intervals. So what we have to do is subtract 360 so we get an angle that is. So we are going to do just that, minus 360 degrees. And if you have 375 minus 360, you get 15 degrees. So 15 degrees lies in the first quadrant because, as you can see, the first quadrant goes from 0 to 90. So the first part of this question, done. It is in Q1. Now the second part, sketch the angle in standard position. So now we want to create an XY axis. Let me use a different color. Your initial side always starts on the positive X, and then your terminal side ends in whatever quadrant it's in. So I put it in Q1 because that's where my quadrant lies. Now, because we subtracted negative 360 one time, we have to do one loop around before we draw our final arrow at the terminal side. So one loop, and then it hits the terminal side, and then you're done. So now how do we do that in radians, you might ask? Well, we want to change this to a decimal. On my sheet, I don't have the decimals, but you should all have the decimals with your radians. You can change them all to decimals. It makes it really easy. So you can take your iPhone, plug in 3 times 3.14 divided by 7, and you get 1.35. So going off of our sheet, that would put this angle also in quadrant 1. The difference when we draw it now is that we don't have to do a loop because we didn't have to subtract 2 pi. So we draw our terminal side in Q1. Initial side obviously is on the positive x-axis. And now our arrow is going to be right there. It's going to be a little arrow just showing that we're starting here and going that way. When you go to do this one, it's negative, your arrow is going to go the opposite direction. And I'm also going to post an answer key to this worksheet so you'll see the answers regardless, but just giving you some tips on how to do the other ones. All right, so the next section is convert the following angle measures from degrees to radians. Let's see if I have that note sheet. So this was the one, if I don't have it, that you were doing. Oh, I do. Okay. So it is this packet, 4.1, radian and degree measure, and right here, conversions. So this is what you want to take out to do this question. So convert the following angle measures from degrees to radians. Write your answer as a simplified fraction. So if you look at your conversion sheet, it says to convert from degrees to radians, multiply degrees by pi radians over 180 degrees. So we're going to take 300, multiply it by pi over 180. Okay. So now we want to write it as a simplified fraction. So we're going to multiply across top and bottom. We get 300 times pi, so 300 pi over 180 degrees. So we don't want to convert that to a decimal. We don't want to multiply anything out in the calculator. What we want to do is simplify it. So I'm actually going to change this to a blue marker to simplify. So my favorite thing to do when both of my numbers end in 0 is start my simplifying process by just taking those off. 'Cause if you have two numbers that both end in a 0, you can do that. So now we have to think of if we can simplify this fraction further. I know we can divide both of those numbers by 3. I know we can divide both of them by 6. And I think that's as far as we can go. So if we divide both of these numbers by 6, 30 divided by 6 is 5, and 18 divided by 6 is 3. So this would be my final answer. So that's what you're going to do for B. I guess I have two B's here, both of the B's and then D. So make sure you're writing it as a simplified fraction, not as a decimal. Now it says convert the following angle measures from radians to degrees. So if you look on your sheet, so same page, it says to convert radians to degrees, multiply the radians by 180 over pi radians. So when we do that, get my pen. It's really small. So that says 3 pi over 8, and we're multiplying. I'm just going to rewrite it. 3 pi over 8. Now we're doing 180 over pi. Doesn't look like an 80. Okay, so 180 over pi. So first thing we're going to do, cancel out the pi's. There's a pi on the top and a pi on the bottom. And now we are going to go to our calculator, which in this case is my phone. And we're going to multiply 3 times 180 divided by 8. And we get 67.5. Always make sure to include degrees as your unit. So this one you do want to plug into the calculator. It doesn't say write it as a simplified fraction. So that's how you know. Let's say you have something like B. So I'm going to do two examples here. If we're multiplying this by 180 over pi, there's not a pi with this to cancel out. So we have to actually divide it by pi. So first we would do 1.2 times 180. You get 216. And then divide that by pi. You get 68.8 degrees. So if there's no pi to cancel out, you can't cancel a pi. The last two examples you're going to do have pi, so that will work out well for you. Okay, so here it says find the exact value of the 6 trig functions of theta for the following triangle. So I forgot to put theta in here. You're going to put it right down there. So that is our theta. So we have one side, we have the other side. We need all three sides in order to find the 6 trig functions. So these notes should be the ones that you took for your virtual day previously. So use those when you're doing this. Okay, so the first step here, we need to find the third side. So to find the third side of a right triangle, we use the Pythagorean theorem. So the Pythagorean theorem says a squared plus b squared equals c squared. And my a in this case is 5, and my b in this case is 12. C is always the hypotenuse, so that's the side across from the right angle, and that's the one we're looking for. So 5 squared plus 12 squared, we get 25 plus 144 equals c squared. So when you add 25 plus 144, we get 169 equals c squared. And then we take the square root. So we get 13 equals c. So I'm going to write that in blue. 13. So we're not done yet. Now we have to find the 6 trig functions. So we need to find sine of theta. We need to find cosine of theta. We need to find tan of theta. And not only that, but we need to find the 3 reciprocal functions, which you should have learned from the notes, are the flip of these 3. So sine matches up with cosecant. Cosine matches up with secant. And tan matches up with cotangent. So I like to always write it out like this, have them side by side with the ones that they flip with. This makes it easier. So now we have to think SOHCAHTOA. So I'm going to write that. SOHCAHTOA. So you should have learned about SOHCAHTOA last year, but also in that video. So sine is opposite over hypotenuse. So let's see, what is my opposite? What is my hypotenuse? Well, since my angle is here, when I draw a line across to the other side, that becomes the opposite. And then my other side is the adjacent. And we know 13 is the hypotenuse. So when I put this into my trig functions here, sine is O over H. So 12 over 13. Cosine is A over H. So 5 over 13. Tan is O over A. So 12 over 5. Okay. So we got that. So now we're going to flip it for these. So 13 over 12 and 13 over 5 and 5 over 12. And that's how you find the 6 trig functions. So there was also an example of that in the notes that you can go back to. Just a quick side note. So the one that you're going to do, the 7, 6, and square root 13, that one already gives you the 3 sides, so you can skip the whole Pythagorean theorem thing and just do your SOHCAHTOA. All right, so now the real reason I put a video in here is because I want to show you that you can actually do trig functions on your iPhone if you have one. So it says use your calculator to evaluate the following trig functions in degrees, round to 3 decimals. So if you take your phone calculator like this and you just need to flip it, it gives you like all of these different buttons on here, and you will see right in this area. It's really hard to do. Right in this area are the trig functions. You'll see sine, cosine, and tangent. So like for sine of 100, you actually first have to put in the number. So you put in 100 and then sine. That's not what you do on a graphing calculator, but the iPhone does that. And when you plug it in, you should get a really long number that looks like that, and the screen is flipped, so it's kind of hard to tell what it says, but I'll read it. So 0.985, because it says 3 decimal places, so always want to round to whatever it says. What if you have something like secant? So if we go back up here, secant goes with cosine. So it's the flip of cosine, so it means 1 over cosine. So secant of 15.8 would be 1 divided by the cosine of 15.8. So first we have to find what is the cosine of 15.8. So you put 15.8 and then you press cosine, you get a really long number, 0.9622. So keep that in your head, 0.9622, and you do 1 divided by 0.9622, and you get this number, 1.309. So that is your answer, 1.3, nope, 1.039. 1.039. And that's the answer to the secant of 15.8.